with this information regarding his velocity, both horizontally due to how the plane flies, or eastward how the plane flies, and southerly how the wind blows, we can ask, as he makes his way from Chicago towards Cleveland, how far off course is he going to be? Because he thinks he's flying towards Cleveland as he flies eastward, but the whole time the wind is blowing him southward. He's not going to end up in Cleveland after he travels the 300 miles. He's going to end up south of Cleveland. Let's try and calculate that. I think this is very similar to the rowboat being blown off course. So if we set up our coordinate system here and call this X, this Y, and let's call Chicago 0. This distance is covered by the downward velocity of the airplane due to the wind blowing in some time t. We don't know that time, but we can find that time because that's the time it takes the plane to travel from Chicago to where the pilot thinks Cleveland is. That's 300 miles. And since the plane is traveling 500 miles per hour eastward, we can find that time easily by the simple kinematic equation for constant velocity. Your final position is equal to your initial position plus your velocity in the x direction through time. Now our kinematic equations are, we're going to have to be really careful of what's in the x direction and what's in the y direction. Our final position in the x direction is Cleveland, which is at 300 miles. Our initial position was Chicago, which we're going to call 0. Our initial velocity, our velocity in the x direction is the velocity of the airplane, which is 500 miles per hour. And how much time it takes, well, I'm not really sure. I can divide both sides by 500 miles per hour to isolate delta t. So this implies 300 miles divided by 500 miles per hour is equal to, well, the miles and miles cancel. The per hour is now hours. The hundreds cancel with the hundreds, and I just have 3/5 of an hour is equal to delta t. So that's just over half an hour it takes for the airplane to go from Chicago to where the pilot thought Cleveland was. But during that time, he was blowing south. And he's blowing south for 3/5 of an hour, and the wind was blowing south at 100 miles per hour. So his final position, y final, is equal to his y initial, which I'll call this 0. And y final, I can also just call this distance d. But I'll leave it at y final. The velocity is 100 miles per hour downwards. I'm going to call that, in this coordinate system, negative 100 miles per hour. And the initial y value is 0. And my delta t, I've just calculated up here, is 3/5 of an hour. So his final position is 100, negative 100 times 3/5 is negative 300 divided by 5 miles per hour. The per hour cancels with the hour, that's miles. And that's about equal to negative 60 miles So his final position is negative 60 miles. Therefore, the distance that he was off course was 60 miles south. The pilot, after flying to where he thought was Cleveland, was blown off course 60 miles to the south.